Hi, in this training, I will walk you through how to build a neural network to predict housing price using the Boston housing dataset. Instead of classifying something into categories like 0 or 1, we will estimate a numerical value or outcome, such as the price of a home. So for training objective, I will walk you through how to load Boston housing dataset from Keras library, explore and process the data, define deep learning, nor, deep neural network architecture for regression using Keras, and train the model on the training set and evaluate its performance on the test set, and then tune the model for performance improvement. And then lastly, we will evaluate the model performance using the tune model and the baseline model. So for our data set, we will use the Boston housing data sets, which contain various housing related features. This feature will help describe the neighborhood and property characteristics that influence the home value. So some of the features as part of this data set, that's including per capita crime rate by town, proportion of residential land zoned for large lots, and also including like percentage of low statistic population. And then lastly, here is basically our target variable, the median home value, which is represented in the thousands, right? So let's load our library that we needed for this. So that's including NumPy, Panda, Matplotlib, and TensorFlow. And then from TensorFlow, we need to import the load model, early stopping. And then from scikit-learn, we need the utility like a train test split, standard scalar. Okay. And then let's jump into loading the data set. So first, I load the data set from Keras using the Keras library directly, which is the Boston underscore dot load underscore dot data. So this basically load the data set and automatically split that into the training data set and test data sets. So what I end up doing here is basically for easier to model in terms of like exploring the data, inspecting the data sets. I created a feature column and then created a data frame for the train data set, test data set, and then combine it into one data frame for easier analysis and cleaning to follow. Okay, let's look at our data set. So basically, I always perform my standard inspection of the data set, like I'm checking the shape of the data, looking at the data frame information, looking at the first few data, then I check for missing value. If there are missing value, I'll drop it from the data set. Then I check for duplicate row, and if there are duplicate row, I drop that from the data set as well. So here's the result from that code above. So the data set shape is 506 row by 14 features. And as you can see here from the data frame itself, data frame information, there are 14 columns. And here's our target variable. There are 5 and 6 rows each of them, and the data type 64 float. And then here's how the actual data look like. The first 5 rows, as you can see, here's all our features, and then here's our target value. And then here's a printout of the missing value. So there are no missing value, and there are no duplicate row. So the next step is basically in this training, I examine the feature relationship. Um, so to do that, I create a scatter plot to visualize how each feature relate to house price. Uh, this plot help us understand which variable may be more influential to predicting the median value home. So here is just a code snippet for doing scatter plots. So basically what I'm doing, I'm plotting the median value home against each of those features. So here is the result of the plot. And I'll walk you through a couple of plot just to show some interesting relationship. So this one here, the first one is um, per capita crime rate by town versus the value home price. So I guess if the crime rate is low, the value of the home price could be high, right? Range from, you know, all the way high as to 50,000. And then as the crime rate increases, you can see the home price start to drop. So I think that is pretty much a very good indicator that home prices, um, I guess, increases if the crime rate area of the town with low crime rate. And then another interesting point here is the percentage of low status population. So as you can see here, as the percentage of low status population increases, the value of the home also decreases, right? So I think this what is saying is that if you have more low income people or low income people, I'm not sure what the definition of low status in this data set is, but maybe just low income, um, not highly educated, right? So as you can see, that increases the value of the home decreases because they can afford buy a higher home value. Okay. All right. So that is something that's in addition to like instead of doing basic data exploratory, always best to do like a scatter plot of your feature set against your target variable to give you that insight into the data. The next step is to split the data into train and test, and then scale the data to fit into our model. So to split the data into train set and test set, I use the train underscore under test underscore split utility, which automatically split the data into X train, X test, Y train, Y test. For my input, I pass in the data sets um, without the target variable. So I did a drop on that, drop target variable. And then for my output is my target variable, M, which is the median value. And then I set the test size to be 20, meaning that the data set will be split to 80% training, 20% for testing. And then I set the random variable or random state to 500. You could choose any number, but this is to make sure that every time you split the split is always consistent. So that way you can reproduce the error, the result. And then I call the standard scalar to fit the scalar on the training data and transform it. And then transforming the test data using the same scalar after training data. So this is important because it helps the neural network train more efficiently and stably. So basically, this is just scaling the data based on mean and standard deviation. So, and then this is just a display of the training data and test data after it's being split. I like to do this because it gives me an understanding how my split look like, what are the input dimension look like. Okay, the next step is basically building the baseline model. So for the baseline model, I'm using one neuron. Since this is a linear regression, the activation function at the output layer, I'm using a linear activation function. So the model learned to map input feature to continuous prediction. In this case, the median house value or house price. And then here I just build a model. Then I basically do a summary in the model so I can print out below. And then I'm just compound the model using Atom Optimizer with a default learning rate of 0.001. And I'm tracking the loss value. In this case, since it's a linear regression, I'm using mean square error instead of loss entropy as we use for like a binary classification. Okay, and next is basically training the model. So to train the model, I call it the dot fit function, right? So that's basically training the model, and I pass in my input, my output. I'm going to let it run for one epoch, and the default batch size of 32. Then I'm doing a validation split of 0.2, meaning that based on the training data, it automatically split that into 80% training, 20% test. And then I'll save the model so that way I could reuse it later. And then here I'm just evaluating the model. I'm passing in my X test and Y test. So, and here's is the result. So this is like the loss is very high. So this is basically the way you interpret this, right? It's like one neuron learning how to predict one output based on an input, right? So the losses, training loss is very high. It mean square error is 610, validation loss of 542, and the test loss is 554. So it's pretty high. So the base model is not performing well. So the next step is how can we improve the model using a different setting. So in this case, what I try to do here in this code is exploring the model with different hidden layer. For instance, one layer with 32 neuron, and then another model with two hidden layers, 64 neuron by 32, and then also another hidden layer or another model with 128, 64, 32 neuron respectively. And then I also try different activation function, right ReLU and 10H, trying different learning rate, epoch, training epoch, and batch size. And here I'm just creating my defining function for my model with taking input, hidden layer, activation, learning rate. And then here is my training loop or my training logics, right? So basically I'm training the model on the different hidden layer, activation function, learning rate, training epoch, and batch size. And then I monitor the validation loss for early stopping. And then I basically keep track of all the model history. And then here's my training loop, not training loop, but a logic to save the best model. So that way I could call it and use it later on for the validation. And okay, and then here is the output of the training. So I'm not going to run it. It'll take about 4 or 5 minutes earlier. And then here the model stop and then save on the best model to a file. And here's the plot of the training loss versus validation loss. And as you can see at the start of the training, the loss for both training and validation is pretty high, and then it gradually improve. Okay, so here is a comparison of the two model. So here I load the base model, and then I evaluate it with X test and Y test. And then here I load the best tune model and then evaluate it with the X test and Y test data sets. And here is just a printout of the result. The base model, as you can see, have a very high validation loss of 554. And then the tuned model have a validation loss of 9.7. So, all right, let's put all this into practice. So how we can use this for actual prediction of the home value. Okay. So now I'm loading my best model. So, and here in this code, I'll walk through a couple iteration of this to see how that worked. So here I'm basically, I load the best model, and then for my input data, specifically slicing the row 50 to get all the feature from that row. And then I'm getting the exact home value for my target variable, my y-test. And then here I'm just passing my example input into the prediction, right? What I'm predicting should match what the actual true home value is. So let's look at the result. Here's my input. Here's the true medium home value. So this is in a thousand. So this is like 21.9, right? Almost 22,000. And then the model predicted 15, close to 16,000. So the model have an error of 6.4 thousand. Let's change this a little bit. Let's do 75. Put in, I guess for my data set, let's extract row 75. So as you can see here, for that row, this is the input data. The true medium home value for that is 7,000. So this is like what back in 1943, right? So that's why the home value is so low. So and then here's what model predicted. The model predicted 7.7, so 7,000 close to 8,000. So it's in this case the model predict a little bit higher. So let's try one more. Okay, so in this case, here's my input data to the model. Here is the true medium home value, 15,000. The model predicted 14.3 thousand, and I guess the prediction error is 0.66 $600. So pretty accurate. So so the model working well here. Um, there are a lot more you could do with the model, like a lot more tuning that you could do to improve it. So thank you very much for watching this training video.